Hi, and welcome back to yet another supplemental math video. And on today's topic, we're going to talk about GCF. So, what is the GCF? The GCF is, just as the name implies, it stands for greatest common factor. And the GCF is basically the greatest factor that the numbers in question can all be divided by. So, let's take, for example, let's just jump right in. Let's take, for example, uh, the number 9, 6, and the number 24. All of these numbers have numbers in common, right? You probably figure a couple out just by looking at them. But what you want to do, if you want to do them all step by step, you want to take what's called the prime factorization of all of them. And what you do is break them down to what multiplies to get them, the factors. So for example, 9 is 3 times 3, right? So we're done with the prime factorization. So for 9, that'll be 3 times 3. And we're going to do the same thing with the 6. So for 6, 6 is 3 times 2. So just write the factors side by side, 3 times 2. That would give you the 6. And lastly, we have 24. There are quite a few combinations in many different ways you can break down 24, right? Just to prove a point, I'm going to use 6 times 4 rather than 12 times 2, but 12 times 2 is acceptable. You can do whatever you like, and we're just going to keep on going. Just keep breaking down the numbers that can be broken down until you can't break the numbers down anymore. And so another thing, we have 3, 2, 2, 2, right? You don't want to travel back up the tree, for example, and look at the 6 anymore. 6 branched off into 3 times 2. So be careful. You don't want to travel back up the tree once you've broken something down. So anyway, 24 would be 3 times 2 times 2 times 2. So looking at all three lists, for the 9 we have 3 times 3, for the 6 we have 3 times 2, for 24 we have 3 times 2 times 2 times 2. You want to find out what they have in common. So yeah, very important. So what do they have in common? They have a 3 in common, right? In all three of these, you see a 3, don't you? So 3 has to be a part of our GCF. And what I like to do, I like to just cross them out, just so it's one less thing to worry about, one less thing to think about. Do they have anything else in common between all three of them? And the answer is no. As you can see, for the 9, we have a 3 left. For the 6, we have a 2 left. They don't have anything in common, regardless of what's going on over here. So if all three of the numbers in question, we have the 9, the 6, and the 24. If all the numbers in question don't have anything left, then we must say that 3 is the greatest common factor. So moving right along, here's another example. I like to put the word GCF up here just so, whenever I get my hands on those factors, I'm just gonna write them right up there. So let's take another combination on some more numbers. We have 9, and this time, let's use a different color for that one. Okay, so for 9, we're going to go ahead and put x to the 4th for that one. We're going to bring variables into this. Remember, a variable is just, it's in the form of a letter like A, B, X, Y, Z. It's not a number. It can represent a number, but it's not the number itself. Let's see what else we can do. We can do, how about negative 18? And yes, I'm bringing negatives into the bunch just to prove a point, and you will see later that it doesn't really change anything. And how about 27, a nice, somewhat larger number? So for the 9, let's go ahead and do what we did last time. We're going to break it down. That'll be 3 times 3. So we're going to put 3 times 3. And don't forget, this is x to the 4th power. So couldn't you just write 4 x's side by side just like that? Isn't that the same thing? Absolutely, yes. x times x times x times x is x to the fourth power. And now we're going to go ahead and do the same, same routine. We're going to break down the 18. Despite it being negative, you're going to see nothing really happens to what the GCF requires. So 18, let's see what we can do. We can say that's 9 times 2, and then 9 is 3 times 3. So we're going to write those in succession. So we have 3 times 3 times 2, and then we have 3 x's. And then last but not least, we have 27. 27 can be broken down as 9 times 3, and then 9 can be broken down as 3 times 3. And so we can say this is 3 times 3 times 3, and then times 2x's because of the x squared. So for the GCF, what do they have in common? Well, they have a 3 in common here, a 3 in common here, and a 3 in common here. So I'm going to write a 3. And remember, as I find those factors, if they all have something common, I just want to cut all 3 of them out just so I don't, look at it, get cross-eyed or something like that. And let's ask ourselves again, do they have anything else in common? Yes, they do. They have another set of 3's in common. So they have this one, and this one. So we're going to put another 3 next to the 3 that we already put up there. So let's go ahead and cross those out. Now for the numbers, do we have any more numbers in common? No, because as you can see with the 9's, we don't have another number here. Both of the numbers are, they're already crossed out, so there's nothing left. Because there's nothing left here, and there's nothing in common between all 3 of the numbers, that's it for the numbers. So we're just going to stick with 3 times 3 for now. Now, what about the x's? How many x's do you have in common? It's going to be the same deal. We're going to go ahead and count and see what they have in common. So they have an x here, an x here, and an x here. So I'm going to put an x here. Do they have any more x's in common? Yes, they do. They have, oh, let's go ahead and cross them out. Yeah, they do have more x's. They have one here, they have one here, and they all have one here. So we're going to just put one here. Remember to cross off as you go. Now, do they have anything left? Well, this one has 2 x's. This one has 1, but this one, there's no x. So we're done with the GCF. The fact that they have nothing left in common means that we're finished. So what is this expression equal to? Well, simply put, we're going to multiply the 3's together to give us a 9. And we're going to multiply the x's together. How many x's is this? When you're multiplying variables, you just count the number of variables, and there's 2 x's, so this is going to be x to the second power. So remember when I told you that this negative doesn't matter? It's true. The GCF in this case, you can always say the GCF is positive. There's nothing wrong with that. And most of the time it always is. So we are done with the GCF. Okay, so how about we take this a step further and really tie everything together into what you're really going to be doing inside of your intermediate algebra course or your college algebra course. So we're going to take the same information that we just had, but we're going to put it in the way that they will ask you how it's done or how to do it. So we're going to put 9x to the fourth power. Let's just cut everything off. We're going to have 9x to the fourth power minus 18x to the third power. And then the positive 27x squared, we're going to put as our last term. And the instructions are still to find the GCF, but what if they say factor out the GCF? Basically, all the work that you just did to get to this point, breaking the numbers down, writing down what they have in common, you can do it in a more condensed way. So we already determined that our GCF is going to be 9x to the second power. So here's how it's done. You write 9x to the second power like so. You make an open parentheses, and all you do is write down what was left over inside the parentheses, and you close up the parentheses. So do you remember the fact that we had 2 x's left over? We have these 2 x's here. So that's what you're going to write here inside the parentheses, x times x, which is x squared, 2x's. And then we're going to keep going to the next term. Remember, this was a negative 18 in the beginning. So because it was a negative, remember this is a negative here, right? Because it's a negative, you have to make sure that your next term stays negative. And what were you left with in this second term? You were left with the 2 and an x. Whatever you have left over, you want to multiply them together and write it down. So 2 and x, when you multiply 2 times x, you get 2x. And then lastly, we're going to have just the 3. The 3 is the only thing that's not crossed off, right? And so guess what? This is a positive 27 here. So we're going to keep the sign going. We're going to make it into a positive, and we're left with the 3 from the bottom. So just a 3. And now that we have all of our factors in and outside, all our factors factored in, we're going to close it up. So this right here is actually the condensed form, and this is the way that they'll ask you to solve these. They'll say factor out the GCF. And so here's your GCF that you've already, went through the trouble of finding, and you basically divide each and every one of these by that GCF. So that'll be it for the GCF in terms of finding the GCFs of polynomials, and that's all there is to it. Okay, so just one more final example of how the GCF question may be given to you. Factor out the GCF, and it may be given to you in a different form. So let's say we have x parentheses x plus 5 minus 3 parentheses x plus 5. And the instructions are to find the GCF. So let's go ahead and take a look at this. I will admit, when I was first learning this, like when I first laid eyes on this, I was so, in my eagerness, I was just so tempted to just go ahead and distribute these x here and here, distribute this negative 3 here and here, and that is not what we want to do. Remember, keep in mind, you're trying to find the greatest common factor. What do they have common between them? That's what the C stands for, right? What do they have in common? Just by looking at it, without changing anything, do they have anything similar? Yes, they all have x's. That's true. They both have x's on both sides. But look harder. This is x times this whole parentheses x plus 5 here. This is negative 3 times another x plus 5. They both have x plus 5 in common. So do not be tempted to distribute. That's what they want you to do, okay? You want to go ahead and take what they have in common, which is the x plus 5 in parentheses, and you want to factor that out. So I'm going to bring a parentheses just like that, and you're going to see what I mean later. And on the right hand side, I'm going to make an open parentheses to write down what I have left. So remember whenever we determine what the GCF is, we just cross the whole thing out. They both have x plus 5 in common, so I'm going to cross the whole x plus 5 out. And what do they have left over? There's only an x here, and there's a negative 3 here. Remember, this is a negative 3 because the identifier is always in front of the number, and there just so happens to be a negative in front of this 3. So you want to specify the sign when it comes to numbers. So we have the x left, so now we can go ahead and just write an x. And we have the negative 3, so just write it right next to there. And we are done. This is going to be x plus 5 times x minus 3. And that's all there is to it. And you're going to see this is a key component of factoring by grouping. And I'm going to show you that in the next video. But as for right now, we're done. um, I will see you guys in the next video. Please like, comment, and subscribe if you feel like it. And thank you very much.